All right, let's take a look at a couple of quick problems here that can help us put some of those notes that we just took into perspective. First thing we're going to do is complete and balance the following reactions, determine in each case if a precipitate is formed. As I take a look at these two aqueous solutions that we're starting with, again, it's indicative here of a double replacement reaction. So if we switch our ions here, we're going to form potassium nitrate, aqueous, and lead 2 chloride, PbCl2. Now, how did I know that the potassium nitrate was aqueous and the lead 2 chloride was a solid precipitate and not the other way around? It comes down to those solubility rules. We'll take a look at them in class, but it's important that you start practicing them now. Okay, all we have to do now is balance this equation. As we take a look here, I'm going to start with my metals, which are already all balanced. I'm going to go then to my nitrates. If I put a 2 here, that'll balance out my nitrates. If I put a 2 here, that'll balance out my potassium and also balance out my chlorines. So this is balanced with coefficients of 2, 1, 2, 1. Again, this is going to be my precipitate here. Just comes from practice those solubility rules, and we'll take a look at them in class, but you should start practicing them now. All right, as we take a look at question number 2, same idea, different reactants. Again, we can anticipate here a double replacement reaction. We mix these two aqueous solutions together. Magnesium nitrate is going to remain dissolved in solution here. And then our precipitate is going to be silver bromide. Again, that just comes from having those solubility rules locked in your brain, so get practice in. We need to then balance the equation here, and when we take a quick gander, we want to balance our nitrate ions by putting a 2 here and a 2 here. So our coefficients are going to be 2, 1, 1, 2. Balanced, our precipitate is going to be the silver bromide. Wham bam, thank you ma'am. Moving on to question number 3. All right, as we take a quick look at question number 3, it says write the molecular, complete ionic, and net ionic forms of the following equation. Aqueous nickel 2 chloride, so we'll start with that. So nickel 2 chloride is going to look something like this. Aqueous plus aqueous sodium hydroxide, NaOH, aqueous, to give nickel 2 hydroxide, NiOH 2. That's going to be my precipitate. Again, that comes from those solubility rules that are in my noggin from years and years of study. And then lastly, aqueous sodium chloride. Oh, just kidding, it tells me. Oh, man. Aqueous sodium chloride. It's going to be our second product here. Now, we do want to balance this equation before we move any further. As I take a quick look here, the first thing I notice is that I need to balance my hydroxide, so I can do that by putting a 2 here. That will unbalance my sodium, so I can put a 2 here. And in the process of balancing my sodium, I also balance my chloride. So we've got 1, 2, 1, 2 for our coefficients in this balanced chemical equation. This represents the molecular equation. The complete ionic equation, we are simply going to split apart anything that is aqueous in nature. We're going to keep together anything that is not aqueous in nature. So we got the nickel 2 ions and 2 chloride ions. And again, we're doing 2 chloride ions because for every 1 nickel, we're going to get 2 chloride ions in solution. Then we're going to get 2 sodium ions, this time because we got the coefficient of 2, and 2 hydroxide ions. All in solution there, indicated by the aqueous nature in our molecular equation. We're going to keep the nickel 2 hydroxide together because it's a solid. And we'll still have our sodium ions floating around there. and our chloride ions just chilling in solution. So as we take a quick peek here, whoa, I forgot to put a 2 here. As I take a quick peek here, you're looking for the ions that remain aqueous on both the reactant and product side. Whoa. And so this becomes our complete or total ionic equation. And then to determine our net ionic equation, you just want to do a quick peek here and see which ions you have in solution on both the reactant and product side. Those would be our chloride and sodium ions. Our net ionic equation is simply going to be the nickel 2 ion plus the hydroxide ion to form our precipitate nickel 2 hydroxide. Boom. And this will be our net ionic equation, where we are only focused on those things that are actually doing chemistry, not really worried about the people who are just watching it happen. Boom. Moving on.